Hello, in this video, I am going to talk about how to reduce the rational expression. So what is a rational expression? Rational expression is written as a quotient of a polynomial, such as ax squared plus bx plus c over dx minus e. So this is a polynomial. It doesn't have to be quadratic. It could be have a degree that higher than just second degree, such as 4s to the 7th minus 1/2 s to the 2nd plus 2/3 over negative 5s to the 4th plus 2 over 7th. This is also polynomial. This is also called rational expression. So here is an example. If you're given a rational function, x squared minus 4x squared plus 6x plus 8, I want you to calculate the function when x equals to -3. So this is very similar to our polynomial substitution. All you need to do is substitute all of the x in here with -3, but you need to be careful about the negative sign. So here is what I want you to do. Whenever you see an x, you put the square root. You put a square root on it in case you forgot about the sign before you substitute with anything. So now all the x become a, all the x is become a parentheses. You replace all the x with a parentheses, and now you fill in the parentheses with whatever that you need to substitute, such as -3. This is super useful because sometimes if you substitute with a function such as x -3 plus a, then you can substitute the whole thing inside the parentheses. Right now, we don't need to do that. So always get used to put the parentheses. All right. So another reason I want to put a parenthesis to replace x before you substitute a number is because whenever there's a negative sign, you know that, hey, with the parentheses, you know you need to square the whole negative sign. Instead of written in this way, during your calculation, you might forget, hey, there is a negative sign also needs to be square. Does it make sense? Because in the test or in the exercise, it happens a lot. People will end up to getting answer like this. But this is wrong because you want to square the whole negative number. So we don't want that. So always put the parentheses. So I have a positive 9 minus 4 and a 9 minus 18 plus 8. So when you simplify, I got 5 over -10, -1. So simplify it. You don't want to keep the negative sign in the denominator or not a numerator. And since the denominator is 1, that means this is going to be a whole number. Okay, so now how do we reduce a rational function? Let's do some exercise. 15x to the 4th power times y squared over 25 times x squared y to the 6th. Well, when you reduce it, you look at number to number and the same variable with the same variable. So I've got 15 over 25. They have a common factor. The greatest common factor is 5. If they both divided by 5, you have 3 over 5th left. Now, for the function, for the variable, I have a 4 and 2. When you reduce it, you look at the highest one. I will have x, 4 minus 2. However, for the y, in the denominator, you have y to the 6th power. Numerator, you have y squared. So that means your y is going to use the top, subtract the bottom. So when you reduce it, you will have 3 x squared over 5 times y to the 4th. Or if that's hard to you to do it right like that, you can expand in the function like 3/5. I believe that you can do it. X to the 4th means you have 4x multiplied, x squared you have a 2x multiplied. You can use the similar trick to y and x. Now, you expand them, and then you know that, okay, x and x, they cross cancel, y and y, they cross cancel. So what they left is 2x on the top and the 4y in the bottom. That also works. But since we already learned the function operation, we should be how to operate the negative rational function. So we should be able to reduce just simply subtracting the exponent. Okay, another one, another example would be 28 over 8x squared minus 16. Now on the top, it's just a number. But in the bottom, you have a polynomial, right? So you cannot just, okay, 8 and 8, they can reduce. No, but the only way that they can be reduced is the relationship is a multiplication. So that means in the bottom, you want to write the polynomial into some product, or you need to factor it. Okay, we already learned factor in last week. So now let's do it. How do we factor it? So the greatest common factor in this case is going to be 8. I factored 8 out. I have x squared minus 4. And if you remember, minus 2. Okay, after I factor it now, it might be easier for us to find the common factor. 28 and a, they can both divided by the biggest number I can think of is 4. We can start with 4. If they both divided by 4, you have a 7 and 2 left. And now they're relatively prime to each other. So the answer should be 7 over 2 times x squared minus 2. Okay, let's look at another example. If I have 9x minus 3 over 18 minus 6. In this example, you will see two polynomials. It's the most common rational function you will see. The denominator and the numerator, they're both polynomials. So you always start with factoring. You want to factor in both polynomials into the simplest form. So in the top, I got 3. I can factor the 3 out. X minus 1. And then over on the bottom is, 18x squared. No. 18, just 18x, not 18x squared, sorry. So 18x minus 6. On the bottom, they have a common factor 6. So that means what do they remain is x minus 1. Now, remember that these two is multiplication, is product, because when they factor, that means you use these two things multiple together. Now, how can I factor it? Well, x minus 1, they both are the common factor of these two polynomials. So that means this part, they can be factored out. Now, I have 3 over 6 left, and I can continue to simplify it by divided by 3. So now I have 1/2. Okay. Now, another example. X squared minus 25 over x squared plus 8x plus 15. Now, these two polynomials looks a little bit harder than the previous one that we have, because the previous one that we have, we just need to do some simple factoring. This one actually is a special product. If you remember that, the top is, you can view it as x squared minus 5 squared. On the bottom, you have 3 terms. 3 turns, we will try to use AC method or the perfect square. On the top, if it's 2 turns, and we have a difference and square, so this one is the differences of square. So these two are the special product. I want you to memorize it. Okay, on the top, when you factor, I have x plus 5 times x minus 5. On the bottom, AC method. How do we, let's do some review how to factor an AC method. We want two numbers, let's say A and B, when they multiply, is equal to 1 times 15, which is 15. And then we want these two numbers, their sum is equals to B, which is 8. So these two numbers should be 5 and 3. So that means I can factor these as x plus 3 and x plus 5. Now, after I factor it, now take a look. We have a same factor, x plus 5. Now we can factor this out. What's left is x minus 5 and x plus 3. This is the simplest form. One thing I want you to be careful. Now you might say, okay, they have x, they have x. We can factor it. No, this is wrong. You can't just factor x like that because the relationship is subtraction or addition. It's not multiplication. It only works if you see something like x times x minus 5 over x times x plus 3. Here is a multiplication. Now I can factor it. That works. Okay, so that's it for this video. Next time we'll talk more about multiplication and divisions.